Now let's try to write the Python implementation for jump searching algorithm. Let's create a new file called jumpsearch.py. In this file, I'm going to create a class called jumpsearch. Okay, and I'm going to define a function called jumpsearch. And the first argument will always be reference of current object, and the second argument is array that I want to pass, and the third argument is the value that I want to search. Now, as part of the pseudocode, if you remember, first we calculated the block size. So let's define a variable called block size, and it will be square root of length of the array. So the square root, we need to calculate the square root. Let's import math library. From this math library, math dot square root of length of array. But one thing that you have to remember is this math dot square root will give exact result which could contain some floating point values, right? For that, to remove those floating point values and to get the actual integers, I'm just typecasting it into int. Okay, once I have the block size, what is the last index in that block size? That variable is last underscore index, that will be block size minus 1. Okay, now what exactly we need to do? We need to iterate over the array so that we will move the last index to the appropriate last index in the valid block. To do so, what we did, as long as the last index is less than length of the array and the value at this last index, that is array of last index, is less than the value that I passed. If this is the case, what I will do, I will simply move on to the next block's last index. How will I do? That is nothing but we'll simply update the last index to last index plus block size. Okay, by the time we complete this while loop, right, we would have moved the last index to the last position in the appropriate block of array. Now all we have to do is we have to come back to the beginning of that block and we have to search in that specific block either using linear search or binary search. So here I'll be using linear search, but if you want to implement it using binary searching also, you can go ahead and implement it. So to perform the linear searching algorithm, what I will do is I'll simply define a variable called current index, and I will assign it with the starting value or the starting index in that block of the array. That we will get simply by doing last index minus block size plus 1. Okay. Now we will simply need to iterate over the array when current index is less than or equal to the last index and current index is less than the length of the array. Okay, array, then what we will do, we will simply take the value at each and every index, that is nothing but array of current index. If it is matching with the value that user has passed, then we will simply return current index. Okay, at any point if the value is not found in that valid block of the array, what we will simply need to do, we will simply need to return -1. Okay, so this is the linear searching algorithm that I have implemented, but if you want, you can go ahead and you can implement the binary searching based implementation as well. Now let's try to create an object and call the function to validate the result. Let's say the array I want to pass is this, and jump searching also requires the array to be sorted, and let's say the value that I want to pass is 4. Now let's create an object for jump search equal to jump search, and js.jumpsearch pass the array comma value that I want to search. In the end, store the value into index variable. Okay, now let's simply print index. Okay, simply let's go to the terminal and try python 3 searching jumpsearch.py. Okay, we made a small mistake here. If this is not the case, what we need to do, we need to move on to the next index, right? How will we go on to the next index? We will simply increment the current index to current index plus 1. Okay, that is how we will need to move on to the next index. So that's why, since we haven't passed this statement, it was simply, running in the infinite loop. So if I execute the same statement here, I got the index 3, which is nothing but, index 3 has a value of 4. Let's say if I want to search for the value of 7, what I will do, I will simply pass it and call it, and value 7 is available at index 6. Similarly, if I want to search for the value 17, and if I run the program, I got -1 because 17 is not available. Let's say the value that I want to search is 2. If I execute it, I got the index 1, which is nothing but the position of the value 2 in the array. Okay, this is how we actually implement the Python based implementation of jump searching algorithm.